Hello again, guys. Hudson here. Going to do a video covering the surface area of right pyramids. So depending on whether you're Accelerated 7 or Math 7 will depend on your section number, but it is the same content. So here's our learning target you can check out. And you can always come back to this at any point if you would like. So what we have here, first thing you see in your notes, is that we are looking at Misadventure. She has a cardboard of a red pyramid she saw in Egypt, and she wants to try to make it out of this sheet of paper that she has that is 4 inches by 5 inches. So we want to figure out, is this sheet of paper going to be enough paper to make this pyramid when she decides to cut it and tape it together? So we can easily find out how much paper we need for this base right here. It's going to be 3 by 3, or we can count the boxes and we can see it's 9 square inches. Then we can look at these triangles, and actually one trick that I can use that the smartboard's really nice for is if I look at this triangle and I actually move it down and pair it with this triangle, I can see that it actually becomes a parallelogram. I could also take this part of this triangle and move it over to here, which would leave me with only this shape, which would be a rectangle. And notice that each triangle covers half of that. So what we see is that triangles are always going to be half of the area of a rectangle, which of course we find by doing base times height. So we always use the formula for triangles. Area equals 1/2 little b times little h. So we need to figure out the area of these triangles. I can actually group them together in pairs. So if I look at this triangle, base of 3 and a height also of 3, then we can look at each of them as being 1/2 times the 3 base times the 3 height. But since I have 4 of them, that's then going to multiply by 4 triangles that I have. So the easiest thing I can do first is 1/2 times the 4, and that's going to give me 2 times 3 times 3, and that is going to give me, my 3 times 3 is 9, times 2 is 18, and that'll be 18 inches squared. So if I add my 9 inches squared that came from the center square there, I see that in total I need 27 inches squared. Now when I look at my piece of paper over here, I want to look at what area I have in the total piece of paper. And since it's a rectangle, we know that area would be base times height, which would just be the 4 times the 5. And of course, this could be base times height or length times width or whatever you want to call it. And 4 times 5 ends up giving me 20 inches squared. So it looks like I do not have enough paper to make that entire image. Moving on into our lesson, you'll see that when we find the surface area of pyramids, it's very, very similar as the surface area of prisms. The big difference is now my lateral faces are all triangles, so they're all half of what they were before. And finding my lateral area now involves the slant height. So when we talk about the slant height is the distance from the base of the triangle at the edge, so right here, up to that vertex on the side. We cannot take the vertical height. That is not the height we're looking for. We're looking for the slant height. Now when we move on into volume, we will use the actual vertical height of the pyramid, but right now we want only the slant height, and make sure that you notate that we call that L. It's our slant height is a cursive L. I'm actually going to let this play for the lateral area of the faces or of the pyramid because I think it's really good. So give this a shot.
The lateral area of the pyramid is the total area of its lateral faces. Suppose the perimeter of the base is P and the slant height is L. You can unfold the lateral faces of a pyramid into a group of triangles. Notice that the lengths of the bases of the triangles added together equals the perimeter of the base of the original pyramid. and the height of each triangle is the same as the slant height of the pyramid. You can form a parallelogram by splitting the triangles into two halves and putting them back together. The lateral area of the pyramid and the area of the parallelogram are equal. So the lateral area of the pyramid equals the base of the parallelogram times the height of the parallelogram. The base of the parallelogram is 1/2 the perimeter of the base of the pyramid. And the height of the parallelogram is the same as the slant height of the pyramid. So the lateral area of a pyramid equals 1/2 the perimeter of its base P times its slant height L.
So the other way that we can think about this formula is that our lateral area is going to be the perimeter times the slant height times 1/2, because they're all triangles. If I look at these as each the individual triangles that they were, we see that each one would need to use that 1/2 base times height, and then of course the base really comes from the entire perimeter all the way around that base shape. So either way, if you remember that our lateral area is going to be 1/2 of what it was when we did prisms, that will help you out. But instead of using the vertical height, again, we use the slant height. And then for total surface area,
The surface area of a pyramid is the sum of the lateral.
Sorry, we'll get that to stop. It's the same thing as prisms, except we only have one base. So now there is no 2 times the big B. It's just your lateral area plus a single base. So you got to be careful with that, because a lot of people will make mistakes. They'll try to double the base, but we only have one of them. So on this first example here, we see that we're trying to find the total surface area of this pyramid. And we know that we can flip shapes, we can rotate them, we can move them around. So I'm going to actually leave here and jump over to our notes to make sure that I'm covering the same thing as you. So make sure that you've highlighted, circled, or starred something to help you see the difference in these formulas. And make sure that you've notated that your cursive L is actually the slant height. So please make sure you've got that. When we come on to this pyramid, we want to first either decide if we want to do big B or lateral area. Big B is really easy, so I'm going to start with that. We're told that this is a square pyramid, so the base is going to be square, so we know that if the length is 12, the width is 12. So I can just do 12 squared, which is 144 feet squared, and that will be my big B. We move on to finding the lateral area, and again we want to set up 1/2 the perimeter times the slant height. Never use H here, because it'll goof you up. Always use the cursive L so you remember it's the slant height. So we need to determine what's the perimeter. Well, my perimeter is just going to be 4 times that edge length, because I have 4 edges, all of 12. And then the slant height, we're told right here, is 10. So if I drop down with my math, this is going to be 48. This is going to be 10. So if I do 1/2 of 48, that's actually going to become 24 times 10. That will give me that the lateral area is 240. And of course, that would be feet squared. So now to find the total surface area, I'm going to bump up just because I'm running out of space. The total surface area of that would be the lateral area plus one of the bases, just the single base. So my lateral area was 240. My single base was 144. So I add those together and I get that the total surface area is 384, and we gotta have a label, feet squared. So try the got it on your own. I'm actually going to cut the video right here, so come back for part 2 only once you've tried the got it on your own. Find the total surface area for that pyramid right at the bottom of your page, and then start in the next video to check that answer and see the rest of the lesson.